fun begin. So what we're going to take a look at to begin with is just a quick refresher of the way absolute value works. So, I'm not going to make you go through it because I'm sure that this is a little bit elementary for you guys. But the way that this ends up working, well, maybe you can describe it for me. So how does the absolute value work?
Distance from 0 to 0.
That's a good explanation. The distance on the number line from 0. Did you have another one?
This comes out positive.
It just comes out positive, right. So that's the most common one that people are told. So the reason I'm bringing it to your attention is that's not very helpful for you in grade 11. In grade 11, you have to think about it a little deeper. So the definition that we're going to use in grade 11 looks like this. And as long as you go back to this, then solving the equations is going to always come back to this one method. Okay, it won't help you to think always make it positive. Okay, so here's the way the definition works. We need something mathematical so that we can actually work with absolute values. If we're a negative number, then what the absolute value does is it multiplies it by a negative. So this is the way you want to think of it, is when I have a number like negative 8 here, what the absolute value is actually doing is it's going negative 8 and gives me the answer 8. Then there's actually a process that's happening. Something is going on that I can actually do some math on. It's very hard to describe the math that just says ignore minus signs. Okay? If it's greater than or equal to 0, like these ones here, then nothing happens. So we just leave it the way it was, unchanged. Okay? So that becomes do nothing if it's positive, multiply it by a negative if it's negative. That's the definition you want to remember. Okay? So if you take a look at the first equations, this is why you're going to want to think about it this way, is there's actually two possibilities here. There's one time when 2x minus 3 equals 5 we'll have a solution to this equation, but there's also another time when 2x minus 3 equals negative 5 that it'll have a solution. Because if it was negative 5 and you put it back into the absolute value, it comes out as positive 5. So what we've just done is we've done one case with a positive and one case with a negative, just like these have here. So, Mr. Mandoli, how are you? Okay, so this is how you're going to break up your equations. For the first type is one positive, one negative. That means for this answer, I get one solution of x equals 4. And for the other one, I get a solution which says, let's see here, 2x equals negative 2, so x equals to negative 1. So there's two possible solutions here, negative 1 and positive 4. Okay? So, your turn now. Try solving it with this equation. 1 minus 2x is absolute value equals 9. Okay, so again, if you think about there's one positive case and one negative case, you end up with two equations. And this will give me negative 2x equals 8, so x equals negative 4. And on this side, it's going to give me negative 2x equals negative 10, so x equals 5. So those are the solutions for this equation.
Yeah, that's nice.
Sorry, did I?
No, I mean, that's fine.
Oh. Okay, so far so good, I hope. Let's take a look now at when we change it up just slightly. Instead of having a constant, we're going to have an equation on the other side. Now, one thing you have to recognize about this is seeing the picture is going to help you understand what happens here. So we're going to take a look at the picture after we solve it. So let's try and solve it the way we did last time, which was to say there's going to be one answer when it's positive and one answer for the negative. So we still have two equations like we did before. 3x plus 2 is 2x plus 3. And another equation which will be 3x plus 2 is negative 2x minus 3. And that means I get x equals 1. And what do I have here? 5x equals negative 5, so x equals to negative 1. So these are my two answers, but something tends to, we get two answers and, you know, it feels good. We think we're on the right track here. We actually need to double check this and make sure that it's true. And I'll show you why that is against the picture in just a second. But let's double check it here. So when we do this and we plug it in for 1, I get 3 times 1 plus 2. Is that equal to 2 times 1 plus 3? So that'll be 5. Is that equal to 5? Yes. So this solution works. No problem. Now let's double check this one over here. And we'll see if that compares to this. So that means negative 3 plus 2. It's going to have an absolute value of 1. And is that equal to positive 1? So yes, this one works for both solutions. Okay. It is possible, however, that one of these solutions may not work. So let's try another graph, and we'll see if this one's going to work out the same way the other one did. Is there a question? Did I?
Negative 1.
No? Okay, thank you. Good, clarify. Keep going. That's fine. So what I'm going to show you why we need to double check these is what the pictures of the graphs look like. So just bear with me while I scoot down to the end of this. So here's what I mean by the picture. So if you have one graph, let's just say we're comparing absolute value of x plus 1, and I'm comparing it with the graph, say I want it to be equal to the graph, maybe I want it to be x plus 2. So I'm going to draw them fairly quickly for you. The pictures, the accuracy is not as important as what comes out from the graph itself. So this V-looking graph here, this is the absolute value graph, because the line wants to become negative like a normal line would, but it bounces itself up because of the absolute value. So this here is the absolute value graph, this V. And this straight line is the lines you're normally used to working with. If you think about the way this picture works, you see those parallel lines, it only lines up one time. It does not cross the graph any more than that once. It's also possible that I have an absolute value graph and a line that goes through like this. So it's possible that it happens twice. Right? And it's also possible that I could have an absolute value graph and a line that never meet up. So what does this kind of sound familiar to you like? It's like a parabola, right? It's kind of like when we were solving for parabolas. So this could be like the imaginary solution, the one solution, no solution. The same thing happens, but in this case we have to double check. We don't have the discriminant to tell us. We have to double check our own work.
I don't think that works, the second solution.
Negative 1? This one here?
Yeah, because if you actually substitute that solution into the original equation, it's 1 equals negative 1.
If I put in negative 1, this will be negative 3 plus 2. So that's negative 1, right?
That's the absolute value is 1.
So it becomes 1. Then negative 2 plus 3 is still positive 1. That's okay. It's the thought that counts.